Blockchain is evolving fast, and the next big shift is here. It's called modular blockchains. But what does that mean? Why is everyone talking about it? And how is it different from traditional blockchains today? You'll understand it clearly. Let's break it down step by step. Starting from the basics. Traditional blockchains are monolithic. That means they do everything themselves. They handle execution. They handle consensus. They handle data storage. All in one place. This is simple, but not scalable. It creates bottlenecks. Ethereum struggles with this. Bitcoin too. When a blockchain tries to do everything, it becomes slow and expensive. That's the monolithic problem. More users means more congestion. More congestion means higher fees, and higher fees push users away. That's where modular blockchains come in. They break the blockchain into layers. Each layer focuses on one job, and does that job extremely well. Think of it like dividing a company. One team handles execution. One team handles consensus. One team stores the data. Each layer becomes specialized. And specialization brings efficiency. It reduces network stress. It improves scalability. And it allows massive growth. Without breaking the chain, in modular blockchains, execution is separated from consensus. And data availability is separate too. These layers communicate with each other, but they don't depend on each other. That gives developers more freedom, and users get faster, cheaper transactions. A win-win system. Let's understand each layer clearly. Starting with execution. The execution layer runs transactions. It processes smart contracts. It does the calculations. Think of it as the computer of the blockchain. Rollups live here. Optimistic rollups and zk-rollups. They handle computation off-chain and reduce workload for layer 1. This is modularity in action. Now, the next layer, consensus. The consensus layer secures the network. It decides which transactions are valid. It creates the chain of blocks. Ethereum uses proof of stake for this layer. Bitcoin uses proof of work. In modular systems, this layer focuses only on security, not on computation, not on execution, just security and ordering. Now let's look at data availability. The data availability layer stores the transaction data. It keeps everything accessible, fast to verify, and impossible to tamper with. Celestia leads this category. It provides data availability for multiple blockchains, meaning developers can build chains without building storage. This unlocks massive scalability and reduces barriers for new projects. That's the power of modular design. Modular blockchains bring flexibility. Developers can mix and match layers. Choose the execution they want. Choose the consensus they want. Choose the data availability they want. And build the blockchain they need. Not a one-size-fits-all system, but fully customizable architecture. That's why modularity is called Web3's next evolution. It unlocks a world of new blockchains. Faster ones, cheaper ones, more secure ones, highly specialized blockchains for different industries. Finance, gaming, supply chains, even social networks. All powered by modular layers. This is the future of blockchain infrastructure. It's scalable, flexible, and unstoppable. And that's why modular blockchains are changing Web3 forever.